So hello everyone, I'm Jay and welcome back to my channel. Today I will show you how you can use Drizzle in an AWS environment. I personally had a struggle integrating Drizzle in our serverless architecture and therefore wanted to share my insights with you. So let's get started with a high-level view of our project. So this is just a small diagram about our architecture. So basically we have an API gateway, and then we have different lambdas serving different needs. And each lambda, of course, needs then a connection to our RDS database, in our case, a Postgres database. And normally what we would use is from AWS, the library, and where we need to write raw SQL. And this is, in my opinion, not a good practice, and therefore we would like to add the Drizzle. So we have then here some kind of abstraction layer where then Drizzle as our ORM is taking care of all the interaction with our database. And what we will do is we will therefore write a function that will initiate the Drizzle client. So we basically call a function, and this function then gives us back the Drizzle client, and then the Lambda can use the Drizzle client to interact with the database. Let's start by installing all the dependencies that we need for Drizzle. So according to the documentation, these are the packages. So Drizzle -orm and then PG as well. And then the Drizzle kit as well. Okay, the Drizzle kit is a CLI companion for automatic SQL migrations, generation and stuff like that. Yeah, but we will see this in a later point as well. Now that we have the packages installed, I will create here a new folder called db, and here we will create client.ts. So this is where we define our Drizzle client, and I would say let's start by creating a new function. Call this function init Drizzle context, and this is an asynchronous function. Okay, so we will need the client from Postgres, and we will need Drizzle from drizzle-orm, and here from the no Postgres package. So the first thing that we need to do is create the client and the connection string. So we need therefore step 0, the connection string. How? Yeah, we get this connection string from, or we need to build it by ourselves because the credentials are stored in the Secrets Manager, right? So we need to define another function that is taking care of fetching the credentials and building up the connection string. So let's define another function, and let's call it fetch db secret. And this is a promise from type string. And then I would just copy and paste here the boilerplate float that you also would get from the Secrets Manager service. So first of all, we check if the connection URL in the environment files is set. If yes, then we just return it. Otherwise, we will get here the new client from a Secrets Manager client with the region where the Secrets Manager are stored. So in my case, it's Europe West 1. Then we use the client to send a get secret value command. Let's import this. And here it's important that we need to pass in the secret ID. And this is normally the one that we used here when we defined the credentials. So this part here. And now you see why I'm using here the environment variable, because later then I can use it just like here. Otherwise, I have defined here a fallback, but this is not correct. Sorry for that. I need to modify it to this one here. And then the response will give us a secret string. And in there we have like, this is an object where we have the password, host, port, username, as you're used to from a Postgres credential. And here I'm building up the connection string in a Postgres friendly way. Okay. The last part is then we set this environment variable, the connection string, because then we don't need to make this call later on again. Then I'm returning the connection string. So we have here now the connection string. And what we then need to do is try to connect. Then our Drizzle comes in. We pass in here the client, and then the second parameter is an object where we need to define the schema. The schema, let's define it. So here from the drizzle-orm PG core, we're using the PG table to say, hey, we have a table called users, and in there we have like the attributes of an ID. Yeah, this is the primary key. And we have the first name, last name, email, but this is like here camel case that we're using in our code, but the real table names are like this one here with snake case written, and therefore you have a good mapping, easily done with Drizzle. And of course, all these should have an value in it, therefore it's like not null, and the email is unique as well. That's it. Then say if this works. No. So we need to import this schema. Then we can return our drizzle-orm variable called db. What I forgot is we need the drizzle config as well. So inside our db folder, we create a new file called drizzle.config.ts. And the drizzle config, you see it's coming from the drizzle kit. And here we define in our application, every schemas are in this specific folder, okay? And the migration should be like in this folder. We are using Postgres, and normally if you would not use the Secrets Manager, then you can also specify where the DB credentials are, but in our case, we don't need this. So let's define in our project where the schemas are all stored. It's like very easy. So the path names are from the root. So we are here now in the libdb folder. So it's like libdb, and there in our schema.ts, there are all schemas. There are also like other notations that you can use, for example, with the wildcards here to fetch all the different schemas inside of a nested folder. But let's have a look at the documentation to get more information about that. So now we need to define the migrations, where the migrations will live later on. Also like lib and migrations. This folder will then automatically generate it, and the driver is PG Postgres. Now we have our client, we have our schema, we have our Drizzle config. So how can we use now Drizzle client in our Lambda? Easy. Here in our Lambda handler, we call this function now init Drizzle context, okay? But this of course is an asynchronous operation, therefore we need await. And here you can then see now we have, because we've defined our schema, we have now this users object here, and here we can call find many, and also we need to await this call again. And what we then can modify this one here, users, right? Just at the moment we have done everything, but only on the code side. And now, so if we look at our schema, we're expecting that there should be a users table, right? But we only have an empty Postgres database at the moment. So how do we get this table into our database? So we could also like manually do this, but this is not a good practice at all. We will do the Drizzle kit for this. So especially we are using migrations to achieve that. So every time if you add something, remove something on a database table side, you document this change in form of a migration, and then you apply the migration. And then the idea is, so every migration have a timestamp so that we know the order, and then we have like all the changes documented as migrations. And then if a other colleague would, for example, spin up its own database, then he could easily apply all the migrations and would have like our up-to-date database status. So in order to create now this user table from Drizzle side, we need a script for this, and I will call this the migrator script. I prefer the script. So let's import also the remaining parts here. The fetch DB secret, because of course In order to connect to our database, we still need a connection URL, and therefore we leverage again our fetchdb function. And this is done here in the connection. And what we do then is again using the drizzle call here with the schema as we've done in the client, okay? So that we have the representation here as db, and then we can call migrate from drizzle, where we then also need to specify where all the migrations live, and then we run the migration. Okay, but first of all, we need to then, so this script is taking care of applying the migrations to the database. So now let's create our first migration. Therefore, we use the drizzle kit, okay, and go into our package.json. Here I've prepared also the commands for this. With drizzle generate, we can generate our migrations based on the schemas that we have. And we do this with the drizzle kit, generate pg, and then I used here the config flag to specify where the drizzle config is in the project. So let's run this command, drizzle generate. Okay, unknown option, drizzle -kit, generate. So I got an error that I don't know what exactly, but I need to downgrade drizzle-kit to the version 20, and now I'm able to run my generate command as I'm used to. Some changes about the generate command in the next version that are not fully grasped. So if you can fix this and share it as well, that would be very welcome. Now we have like our, because we specified the config location here, drizzle-kit is able to generate the migrations, and we see here our first migration file. It's called here edit quasimodo, and now we are using our script to apply this migration, okay? But first of all, I need to pass in my AWS environment files so that the script has the information to connect to the Secrets Manager. So I will copy it here. Okay, cleared, and now I can run drizzle migrate. We have our first problem. The fetch connection URL secret. Can't find the specified secret. Maybe I forgot to deploy it. Let's check. Hey, so finally it worked. Yeah, the missing part was the security group, and they're here adding the ingress rule so that we are like allowing the Postgres port over the VPC. Then we have the connectivity to our database. So here, this is was the missing part, to also referencing the security group, make sure it's still public accessible, and then the migration script should work. Okay, now we have applied the migration to our database. There should be now the users table at the moment. And what we will do now is, of course, check if we then can finally retrieve the data. Now let's try to hit our endpoint and to see if we get the empty array, because we have no data at all in there. So I will use here Insomnia, hit the endpoint, and we can see we got an internal server error. This is what I wanted to achieve, because we have missed one thing, but I want to show you what's going on, because our Lambda function does not have the right permissions to access the Secrets Manager. What we need to do in order to allow our Lambda function to access the Secrets Manager, we first of all give our Lambda function here an initial policy, where we create here a new policy statement. The action is Secrets Manager gets secret value, and the resource is of course the Secrets Manager, our region, our account, and then the secret followed by the secret name that we defined in our environment variable called PostgreSQL secret. And here, don't forget the wildcard so that we can access every value inside of it. And also what we need to do is then from here, credentials, and we defined it here, secret grant read, and here our Lambda function. So I deployed the newest changes regarding the authorization for the Lambda. And then if we hit Insomnia again, yeah, we can finally get our empty array. I will now add some boilerplate data inside the Postgres database manually, and then we will see if we can fetch the data then. So I retrieved all the secrets from the Secrets Manager and then used dbweaver to connect to this database. Here we can see our users table as well. We have also here the Drizzle schema. Drizzle internally uses the Drizzle migrations to keep track of all the applied migrations. If we then look here, you can see it. And yeah, now let's create our first user here. By clicking here the plus button, I will fire. My email is test@gmail.com. Okay, and then save. This is then automatically increased by 1 the ID, and now we have our entry. Great. Now let's hit Insomnia again. Yep, and we can see it retrieved the data. That's the tutorial in general. So the hardest part, of course, was to retrieve the connection string or the secrets from the AWS Secrets Manager. We use therefore our little helper function called fetch_db_secret, as you can see here. And we also have our migration script that you can leverage and expand further. You can also see all the created migrations as well. And overall, thank you for watching and see you in the next time. And here's a little trick if you don't know. If you write cdk destroy, all the resources that we recently deployed are getting shut down and we don't have any cost. Okay, great. See you next time.